visual, a black screen, the faint sound of a heartbeat, slow, steady, then flatline, silence. What if I told you that living forever is not only possible, but that the physics that allows it already exists, and before you roll your eyes and say, here we go, another sci-fi fantasy, let me be bold, maybe even a little arrogant, you don't die because the universe wants you to. You die because of bookkeeping, cosmic bookkeeping, and the laws that govern it are the same laws that govern stars, galaxies, melting ice cubes, and the slow decay of everything you've ever loved. But here's the twist. Those very same laws, the ones that seem to guarantee your death, also contain a loophole, and that loophole is extraordinary. So let's begin somewhere simple. Have you ever watched an ice cube melt? Sitting on a table. Time-lapse as it slowly melts into a puddle. Time-lapse as it slowly melts into a puddle. Time-lapse as it slowly melts into a puddle. Order dissolving into disorder. Solid structure collapsing into randomness. You never see the reverse happen. You never walk into a room and find a puddle of water that spontaneously jumps up and assembles itself into a perfect ice cube. Why not? Because of a single word that quietly rules your life. Entropy. Entropy. Entropy is often described as disorder. But that's not quite right. It's more precise and more unsettling. Entropy is the number of ways things can be arranged without you noticing the difference. Let me explain. Imagine I give you a brand new deck of cards. Pristine deck of cards fanned out in perfect order. Ace through king. Fresh out of the box, perfectly ordered. Ace through king. Hearts, diamonds, clubs, spades. That's one very special arrangement. Now shuffle it. Now shuffle it. The number of possible arrangements of a 52-card deck is about 10 circumflex 68. That's a 1 followed by 68 zeros. A number so large that if every atom in the observable universe were a person shuffling decks since the Big Bang, you still wouldn't exhaust all possibilities. The ordered deck, that's one arrangement. The messy shuffled deck, that's almost all of them. Order is rare. Disorder is overwhelmingly probable. And that is what entropy really means. Now zoom in, way in. Visual camera dives into a human body, past skin, into cells, into molecules, into atoms, vibrating. At the microscopic level, your body is just atoms. Carbon, hydrogen, oxygen, nitrogen. They don't know they're you. They don't know about birthdays or heartbreak or your favorite song. They obey simple rules. Newton's laws. Quantum mechanics. They obey simple rules. Newton's laws. Quantum mechanics. Electromagnetism in sky. And here's the shocking part. At that microscopic level, the laws of physics don't care about time. The equations work forward and backward. If you film two atoms colliding and play it in reverse, you can't tell the difference. Physics, at its core, doesn't prefer past or future, so why does your life only move one way? Why do you age forward, never backward? Why do you age forward, never backward? Why does the ice melt, but never unmelt? The answer is statistical. At the microscopic level, reverse aging isn't forbidden. It's just absurdly improbable. Imagine all the atoms in your body, around 10 circumflex, 28 of them, randomly rearranging into a slightly younger configuration, repairing DNA errors, fixing misfolded proteins, rebuilding damaged cells. Is it allowed by the laws of physics? Yes. Is it likely, about as likely as that puddle, spontaneously leaping back into an ice cube, while also singing opera? The laws of physics say, sure, go ahead. Probability says, don't hold your breath. So here's the first profound realization. Death is not a hard rule written into the equations of the universe. It's a statistical avalanche. Now here's where it gets interesting. Because living systems, like you, are not passive ice cubes. You are not a closed system, visual, a glowing human silhouette exchanging light and particles with the environment. You eat, you breathe, you radiate heat. You are constantly exporting entropy into your surroundings. Think of your body as a house that's constantly under attack by microscopic termites, random molecular damage. But you have repair crews, proteins that fix DNA, cells that recycle waste, immune systems that hunt invaders. Life is not the absence of entropy. It's a rebellion against it, a local temporary rebellion powered by energy. Here's an analogy. Imagine you have a messy room. Left alone, it gets messier. Clothes on the floor, dust gathering, chaos creeping in. But if you constantly clean it, using energy, you can maintain order. You can even improve it, but there's a cost. You have to eat, sleep, work. Now imagine trying to keep that room perfectly clean forever. Eventually something breaks. The vacuum fails, you get tired, dust wins. That's aging. Not because the universe demands it, but because the universe demands it, but because maintenance is imperfect. Now here's the radical idea. What if maintenance didn't have to fail? Biology is physics. There's no magical aging force. There's no magical aging force. Particle, no gremlin sneaking into your cells. Aging is accumulated damage. Damage is molecular misarrangement, and molecular misarrangement is in principle correctable. Already we see hints of this. Certain organisms, like Hydra, don't show clear signs of aging. Some jellyfish can revert to earlier life stages. Cells in your body can be reprogrammed to a more youthful state. This isn't science fiction. This is thermodynamics in action. You see, immortality isn't about stopping entropy. That's impossible. The second law of thermodynamics says total entropy always increases. But it says nothing about local decreases. Your refrigerator decreases entropy inside by increasing entropy outside. Life does the same. The universe doesn't forbid eternal life. It just sends the bill somewhere else. And as long as you can keep paying that bill, by consuming energy, repairing damage, exporting disorder, there's no fundamental law that says you must die. Let me say that again. There is no known law of physics that requires you to age and die on a fixed schedule. There are practical limits, engineering challenges, astronomical probabilities, but not of fundamental probabilities. Now, before we get carried away, let's confront the counter-argument. Okay, you might say even if biology can be repaired, eventually the sun will die. The universe will expand, everything ends. Yes, on cosmic timescales, stars burn out. The sun swelling into a red giant. In about 5 billion years, our sun will swell into a red giant. And about 5 billion years, our sun will swell into a red giant and make Earth uninhabitable. But that's not a biological limit. That's a relocation problem. Humanity could, in principle, move. And even the heat death of the universe, the ultimate fade into maximum entropy, is not tomorrow. It's trillions upon trillions upon trillions of years away. And even there, things get strange. Because as long as energy gradients exist, differences in temperature, density, or motion, work can be extracted, and life, at its core, is a machine for extracting useful work from energy differences. The real enemy of eternal life is not entropy itself, It's running out of usable gradients, so living forever isn't forbidden. It's just incredibly hard, but here's the deeper question. If the laws allow it, should we want it? And visual a time-lapse of a human life. Childhood, adolescence, adulthood, old age. Your life is a temporary island of order in a sea of chaos. You are a pattern, an exquisitely complex arrangement of atoms, maintaining itself against astronomical odds. Every second you're alive is statistically miraculous. The fact that trillions of atoms cooperate to produce thoughts, love, curiosity, is outrageous. But here's the philosophical pivot. Would that miracle feel the same if it were permanent? Diab miracle feel the same if it were permanent? Diabolus, the tension builds, the finality arrives, the silence after means something because it ends. If the music never stopped, if it droned on for eternity, would it still move you, Jivan, or would meaning evaporate into endlessness? Scarcity creates value. Probability creates preciousness. The fact that your atoms could have been arranged in 10 circumflex 28 other useless ways, but instead are arranged as you, right now, is what makes this moment sacred. You are the universe experiencing itself in a configuration so rare it borders on impossible, and it won't last forever. Not because physics forbids forever, but because the cost of maintaining order against entropy is staggering. Life is a constant negotiation with chaos, a dance on the edge of probability. At the microscopic level, nothing is trying to kill you. Atoms just bounce, molecules just react. But at the macroscopic level, your level, that statistical drift toward disorder feels like aging, decay, death. Micro, reversible, indifferent, timeless equations. Macro, irreversible, directional, deeply personal experience. That gap between micro laws and macro reality is where mortality lives, And in that gap, something extraordinary happens. Meaning, if you were guaranteed infinite time, would you start that project today? Ident. Would you tell that person how you feel? Would you watch the sunset like it might be your last of eat? Or would you postpone everything into an endless tomorrow? Finitude focuses us. Entropy sharpens us. The second law doesn't just melt ice. It creates urgency. It forces complexity to be temporary and therefore profound. Living forever in the strict physical sense may be possible. In the strict physical sense may be possible. As long as energy flows and repair mechanisms function, there's no cosmic rulebook that slams the door shut. The physics that makes immortality possible already exists in the reversible equations, in the flow of energy, in the defiance of local entropy. You are already performing a small miracle every second you survive. The deeper question is not can we live forever? It's what do we do with the time we improbably have? It's what do we do with the time we improbably have? Because whether you last 80 years or 8 billion, you are still a fleeting pattern in an ancient universe. A temporary arrangement of stardust that can ask questions about itself, that can wonder about entropy, that can imagine eternity. And maybe that's enough. Maybe the true miracle isn't escaping the second law. Maybe it's that for a brief defiant moment. You get to push back against it at all. You get to be a pocket of order that laughs in the face of chaos. You get to love, build, think, create. You get to exist. And that existence, balanced on the knife edge of probability, is more astonishing than any promise of forever. So let me ask you something. If physics doesn't forbid living forever, but probability makes this moment unbelievably rare, would you really trade the intensity of a finite life for an endless one by degree? Would you really trade the intensity of a finite life? I'll see you in the comments.